Well, hi, hello, namaskar. Myself Mahesh Prasad from Department of Physics. As you know, well, dear students, we are in a chapter that is nothing but oscillation. It is a new chapter we are going to deal. In this particular chapter, we are going to study a beautiful phenomena like the oscillation and especially oscillation under this a different type of motion like periodic motion, simple harmonic motion. So these are the concepts we are going to deal in the particular chapter, and these kind of motion we can expect in day-to-day life as well. Like you might have aware that your earth, which means our earth, are revolving around the sun, yes or no, and also different satellites are revolving around our earth as well, and also the moon is revolving around the earth. So these are the basic concept we are come across so far, and now we'll try to understand in terms of physics point of view. Okay, so first motion we supposed to remember, that is nothing but periodic motion. A periodic motion in the sense it is a motion which repeats itself at a regular interval of time. What do you mean by periodic motion? It is a motion which repeats at regular interval of time. So this is what exactly we can expect. So which example I can give for periodic motion? Periodic motion, just now I told, it is a motion which repeats with respect to time. So don't you think our earth is revolving around a nucleus continuously with respect to time? And similarly, the revolution of moon around the earth, also we can expect the movement of the pendulum in a clock. So that also comes under periodic motion. So with example I can give examples like revolution of earth around the sun I can expect. So this is an example I can expect, and similarly we can expect one more motion, that is nothing but oscillatory motion. What do you mean by oscillatory motion? So I'll take one pendulum. What is there on my hand? I have one bob with the thread over here. Now remember, this is right now your bob, whether is there any force which is acting over here? No. Which means your bob is in mean position, which means rest position. So this is a point where we can expect as a mean position, and this is a point where we can expect as an extreme position. So which position is this? Extreme, and here we have mean position. Well, now if I leave at extreme point, don't you think it can take a repetitive motion with respect to its mean position? So continuously this bob is moving towards its mean position. Yes or no? So oscillatory motion, which is nothing but we can expect is the motion which repeats, or if a body moves back and forth towards its mean position, is called as oscillatory motion. If the bob moves, towards its back and forth towards its mean position, is called as what? Oscillatory motion. Understood? Well, and which example I can give? The moment of pendulum, the movement of pendulum, the movement of pendulum towards the movement of pendulum about its mean position, So how it is? What do you mean by mean position? What do you mean by mean position? So this is called as mean position. If the body moves back and forth towards its mean position, we can call it is called as oscillatory motion. Understood? Well, and one more formula, one more relation we have, which is nothing but simple harmonic motion. What do you mean by harmonic motion, by the way? Harmonic motion, it is a motion in which we can expect or which can represent in terms of sine and cosine function. And how? We'll discuss. And basically, your simple harmonic motion is the oscillatory motion. So we can define it is the oscillatory. It is the oscillatory motion. It is the oscillatory motion in which the restoring force is restoring, and you will get one by one. We will discuss one by one. Once you see the definition which I am going to write on the board, based on that, we will try to apply in practical. So the restoring is proportional to. It is proportional to what? It is proportional to displacement about its mean position. About its mean position, and restoring force always directed towards its, or restoring force is always directed about its mean position. What do you mean by this? Obviously, listen properly over here. Right now, your bob is in mean position. Now, if I apply a force somewhat in this direction, right now your bob is in mean position. Now, if I apply the force, what happens? This bob can move up to extreme position. Now, it is a point where, don't you think if I leave at this particular point, it will come back to its original position, correct? Which means, this is the point where your bob is experiencing the restoring force, which is try to regain its original configuration. Understood? So, which means what I can expect? It is an oscillatory motion in which restoring force is directly proportional to, don't you think it has covered some distance? Don't you think if I speak about this is the mean position, and if I apply a force, it will reach out over there, and don't you think it has covered some displacement? Which means your restoring force is directly proportional to the displacement, and also at the meantime, this bob is trying to move towards its mean position, which is nothing but try to regain its original configuration. Yes or no? Yes. So, indication of that, you are supposed to put one minus sign. This minus which indicates the restoring force which is acting towards its mean position. So, if you have some proportional, if I want to write some equation, we need one constant, that is nothing but f which is equal to minus k into x. So this is what exactly you can expect a simple harmonic motion. Simple harmonic motion is the oscillatory motion in which the restoring force is directly proportional to displacement about its mean position, and restoring force is always directed towards its mean position. So this is called as mean position, and this is called as extreme position. position. Okay, so this is what exactly we can have a basic idea about different kind of motion, and we'll see how exactly and what would be its frequency, what would be its time period, and how much time it will take to complete one oscillation, and also we'll try to see what would be the velocity, acceleration, and what would be the energy source over here. So these are the basic concepts. We'll go one by one. Understood? Well. Well, we'll try to have a basic idea about the simple harmonic motion and circular motion. And at the end we are going to get that is the most important formula, that is nothing but displacement relation. Which relation? Displacement relation. Well, and we have to know one more thing. When a particle moving in a uniform speed of a circumference of a circle, foot of the perpendicular from at any point on the diameter gives or which exhibit simple harmonic motion. Understood? If not, we will try to have eye on the diagram which is there on the board. Let us take one circle. Imagine you are one particle which is revolving around a circle somewhat like this. Let us say it is the center of the circle, and this could be the radius of a circle. I will take A as the radius. Now imagine your particle is moved up to point of P over here. Okay? Can I say this could be the diameter? If I take one vertical diameter in y-axis, let us say it is the point A and this is the point B, which is having a diameter. For timing, I will take it as let us say it is x-axis and y-axis also can be taken. Now, foot according to the things which is there on the board, what is mentioned? When a particle is moving in a circular, moving with the uniform speed in a circumference of a circle, the foot of the perpendicular, this is the foot of the perpendicular on diameter of the particular circle gives what or execute what? Simple harmonic motion. Which means if I draw a foot somewhat like this on where, and this could be the diameter, and this is a vertical diameter, and this is a horizontal diameter, and if I connect this particular point P2 over here, can I say O to P is also diameter? O to P is also radius, not a diameter. Radius, it is having a radius for timing. I take it as this is a point where I can expect as R. This OR is located in which axis? Y-axis, and this is the y-axis. I can say this is x-axis, and this could be the y-axis. Are you getting? So what is the length of our timing? I take OR. Here angle is comes in the picture. Understood? Well, so now exactly 45 angle I have marked over here. Now what I wanted to tell here is that what do you mean by sine theta? Sine theta, which is nothing but opposite by hypotenuse. Since not here theta, since theta is exhibited over here, theta is comes in the picture over here, and this is a theta and this could be the theta. Now, what do you mean by sine theta? Sine theta, which is nothing but opposite by hypotenuse, correct? So, sin theta, what I can write? Sin theta is equal to, it is OR, is opposite by hypotenuse, which is nothing but OP I can write. Yes or no? Yes. So, because the theta is exhibited over here, that's why. This is the theta over here. So, it is the opposite theta, we can expect over here in angle. Now, your OR is located in which axis? OR is located in y axis. And what is the value of OP? Can I say OP is the radius of the circle, I can take it as A over here. So now I can write OR is equal to OB into sin theta. Yes or no? Yes. So now OR can be taken as what? OR we can call it as Y is equal to OB can be taken as what? That is A into sin theta, because I can take this as a radius as A for time being. This is the expression for displacement relation. Displacement relation. Understood? Well, this is the one thing. Now, this theta which indicates what? Angular displacement. Where theta is angular displacement. Where theta is angular displacement, I can expect. Now, don't you think your particle is moving with the velocity, angular velocity omega? Now we know the basic formula, that is nothing but angular velocity is equal to displacement by time. So similarly, I can write angular velocity is equal to theta by t, or t I can expect time taken. So now with respect to theta, what I can write over here? Theta is equal to omega into t I can write. Yes or no? Yes. So I can rewrite as this theta as y is equal to a into sin omega t. So this is also possible. Where omega is angular velocity, where t is the time taken. So this is one more form of the same equation. That is the one thing. And one more thing we have to remember, there is nothing but the period of oscillation. The period of the period of oscillation. What do you mean by period of oscillation? It is nothing but number of oscillations. What do you mean by period of oscillation? We can expect as a time taken to complete one oscillation. It is nothing but time taken to complete one oscillation. What is the time taken to complete one oscillation we can expect? It is the time taken to complete one oscillation. What is one oscillation we can expect? For example, if I speak about see, it is a mean position, it is the extreme position, and it is a time taken to complete. See, one oscillation, two oscillation, three oscillation, which means time taken to complete one oscillation, which gives what? Period of oscillation. So similarly, we have a period of oscillation we can expect as t, which is equal to what is if I speak about a circular motion. What is the value I can expect? From here to here we have a pi. If we complete one oscillation, which can take up to time required to complete one oscillation, sense from here to here we have a 2 pi. So 2 pi divided by, so this is a 2 pi divided by, what would be the velocity I can expect? Angular velocity is equal to omega. So this is how exactly we can expect. Basic formula we know, that is the velocity is equal to displacement by time. So now what is the displacement? It has covered over here. What is the distance? Distance is 2 pi, because it has covered one cycle over here. So what is the time taken to complete one cycle? What is the displacement which covers over here? That is nothing but 2 pi over here. So this is nothing but time taken by a particle to complete one oscillation or one cycle also we can expect. Understood? And this is the one thing we can expect. And similarly we have one more term called as the frequency of oscillation. It is called as the frequency of oscillation. The frequency of oscillation, we can call it as, it is a number of oscillation can complete in one, number of oscillation can complete in 1 second. That is nothing but number of oscillation, the number of oscillations can do in 1 second is called as what? Frequency of oscillation. If it is a frequency of oscillation, what is the formula I can expect? Nu is equal to 1 by T. So this is a number of oscillation can complete in 1 second, which means how many oscillation can be taken in 1 second, which is called as the frequency. And similarly, period of oscillation in the sense what? It is nothing but number of, it is the time taken to complete one oscillation. Complete in one oscillation. So here we have 1 by T. So now frequency can be taken as it is nothing but inverse of that. So what do you mean by that? That is nothing but omega divided by 2 pi. Understood? Or else we can write omega is equal to 2 pi nu. So this is what exactly I can expect. Understood? Or else angular velocity I can take omega which is equal to, it is a 2 pi divided by T. So now what is the basic relation we can have with respect to frequency with the time period over here? So we can expect as your frequency which is equal to either omega which is equal to either 2 pi nu which is equal to 2 pi divided by T I can expect. So this is the basic relation we can have, especially whenever we are speaking in terms of frequency of oscillation as well as time or a time period of oscillation, and period is also called as a time period of oscillation. So this is the basic concept we need to know to understand about velocity as well as acceleration as well as the next topic that we are discussing about energy in terms of oscillation. Okay, in terms of kinetic energy, in terms of potential energy. So these are the basic concepts we need to understand by ourselves. Okay. So whatever we have discussed so far, we have started up with the basic concept of period, the periodic motion, oscillatory motion, simple harmonic motion, and we have got a basic idea about what exactly the period is, what exactly the frequency is, and we have discussed about the basic relation of displacement relation. Understood? Well, so this concept keep in your mind until that. And we'll see in our next class. Till that, bye bye. Thank you very much.